Let's talk about the problem overview. The South China Sea is experiencing several overfishing mainly because fishing activities are largely open access, meaning that many fishers can operate in the same area with limited restriction. Weak governance and enforcement make it difficult to control fishing effort, while high demand for seafood further increase pressure on fish stocks. In addition, the use of unsustainable fishing practice accelerates stock depletion. As a result, current harvest rate exceed the natural regeneration capacity of fish stocks, meaning that fish are being caught faster than they can reproduce. This situation reflects the concept known as the tragedy of the commons, where unrestricted access to a shared resource encourages excessive exploitation. In the long term, this leads to declining fish stock, ecosystem degradation, and economic loss for fishing communities. Overfishing has resulted in several major environmental impacts. Firstly, fish stock continue to decline because harvesting exceeds natural reproduction rates. Secondly, habitat degradation occurs as intensive fishing activities damage steep habitats and spawning area. This leads to a loss of marine biodiversity as certain species become less abundant or disappear entirely. As a result, ecosystem resilience is reduced, meaning that marine ecosystem become less able to recover from disturbance and environmental stress. These impacts are directly linked to Sustainable Development Goal 14 Life Below Water, which aims to conserve and sustainably use marine resources. Overfishing contradicts the objectives of SDG 14 because it degrades marine ecosystem, reduces biodiversity, and threatens the long-term sustainability of fisheries resources. Currently, fisheries resources in the South China Sea are under significant pressure due to continuous fishing activities. Most fish stocks are now fully exploited or even overexploited, meaning they are being harvested at or beyond sustainable levels. Fishing activities exceed both the natural regeneration capacity of fish stocks and the economically optimal harvest levels. This means that fish are being caught faster than they can reproduce. And at the same time, fishing is no longer economically efficient in the long run. As a result, fish stocks have a reduced ability to recover naturally and to sustain long-term productivity. Continuous fishing pressure further threatens ecosystem resilience and the overall sustainability of marine resources in the region. In terms of key data, the South China Sea contributes approximately 12% of the global wild fish catch, highlighting its importance as a major fishing region worldwide by CSIS 2023. However, long-term data show a severe decline in fish stocks. Since the 1950s, fish population have decreased by between 70 and 95%, while catch per unit effort or CPUE has fallen by 66 to 75%. This means that fishers now have to exert much more effort to catch fewer fish than in the past. This one also by CSIS 2023. Scientific studies also indicate that most pelagic and demersal species in the region are either fully exploited or overexploited, suggesting that there is very limited capacity for further fishing without causing additional stocks depletion. Research found by UKM at 2024. Furthermore, the density of demersal fish stocks in some areas is only about 1.05 tons per square kilometer, which reflects a critically stressed condition and highlights the urgent needs for sustainable fishery management. Research found by FAO 2022.
So, hello, my name is Muhammad Baim bin Abdul Karim. My matrix number is E24A3409. So, today I'm going to present about economic analysis summary. So, the first one is biological dynamics and regeneration. Marine fish stocks are renewable resources that regenerate through reproduction and growth. These are influenced by environmental conditions and fishing pressure. The logistic growth model assumes population growth is fastest at medium stock levels and slows as it approaches carrying capacity. Growth equations equals to dx divided by dt equals to Rx 1 minus x divided by k. The key parameters is K is carrying capacity, which is 10 million tons, and R is intrinsic growth rate, which is 0.5 per year. Second is maximum sustainable yield (MSY) analysis. The MSY represents the largest harvest that can be taken indefinitely without depleting the stock. MSY stock level occurs at half of carrying capacity, which is the formula is X MSY equals to K divided by 2, which is 5 million tons. MSY harvest rate can be calculated in formula of MSY equals to RK divided by 4, resulting in 1.25 million tons per year. The current crisis is current harvest equals to 3 million tons per year, which is bigger than MSY, meaning that the South China Sea is biologically overexploited and facing serious depletion. So the third slide is economic efficiency MEY versus MSY. Economic efficiency considers profit, which is pi equals to pH minus CH, not just biological volume. MEY occurs at a higher stock level, which is XMEY equals to 6 million tons than MSY because higher stocks reduce fishing costs. In the table given, we can see the differences between MSY and MEY in terms of stock level, harvest, profit, and sustainability. For the first criterion is stock level. MEY stock level, which is 6.5 million tons, is bigger than MSY, which is 5.0 million tons. Second criterion is harvest, which dominates by MSY, 1.25 million tons greater than MEY, which is 1.14 million tons. The third one is profit. MEY offers the highest profit compared to MSY that only offers medium profit. And the last one is sustainability. MEY can sustain higher than MSY that only can sustain moderately. Lowering current harvest today maximizes long-term present value and economic returns. So the last one is market failure and externalities. The tragedy of the commons characterizes the South China Sea due to its open access nature. Open access problem is lack of property rights leads to overinvestment and stock collapse risk. Harvest hierarchy, which is HOA greater than HMSY greater than HMEY, open access harvest is the highest and most damaging. Quantify external costs. The total cost is RM7 billion per year. Habitat destruction costs about around 2.0 billion, which is 28.5% of 7 million. The second one is reduce future catches, which is cost 3 billion, which is for 42.9% from 100%. And the lastly is biodiversity and carbon loss. The two of them shared around 2.0 billion combined. That's all from me. Thank you.
First, the total allowable catch system limits the total amount of fish harvested each year based on scientific assessment. This helps prevent overfishing, improve economic efficiency, and ensure long-term sustainability. It directly supports SDG target 40.4. Second, marine protected area allow fish population to recover by restricting fishing in certain zone. Although there are short-term costs, MPA provide long-term benefits through spillover effect. This policy support SDG target 40.5. Third, stronger enforcement against illegal, unreported, and unregulated fishing is important. Measures such as vessel monitoring system and stricter penalties help protect fish stock and fisheries management. This support SDG target 40.6. Finally, selective fishing technology reduces bycatch and protects marine ecosystem. Although it may increase short-term costs, but it improves fish stock and long-term yields. This supports SDG targets 40.2 and 40.4.
For this section, it provides a critical assessment of the proposed fisheries management policies. It evaluates their economic, institutional, and social implications while also recognizing the limitations and uncertainties of the analysis. Although these policies may involve short-term costs for fishermen and higher enforcement expenditure, they offer significant long-term benefits through stock recovery and income stability. Importantly, the assessment considers different stakeholder perspectives and highlights the need for practical, context-specific solutions to ensure effective implementation within the Malaysian fisheries sector. In conclusion, this study finds that current fishing activities in the South China Sea exceed both biologically sustainable and economically optimal levels. In this situation, it reflects an open access system that leads to overfishing and long-term economic inefficiency. To address this challenge, the report highlights the importance of science-based catch limits, marine protected areas, and stronger enforcement. Overall, sustainable fisheries management is essential to restore fish stock, improve economic efficiency, and support long-term livelihoods, in line with Sustainable Development Goal 14.